Hello, this is an overview of the VR card battle game system prototype, which was built for Oculus Quest using Unity 2019. This was a project inspired from a friend who's a fan of card games. I thought it'd be pretty cool to make a real-time VR battling card game with some deck building in it. High-level overview, the gameplay loop is very simple. You basically defeat your enemies and get rewards, which allows you to build a stronger deck, which then allows you to beat more enemies. You win by reducing the enemy's health to 0 using magical weapons, which spawn from a deck of magical cards. As you defeat the enemies, they provide additional magical cards, which you can then incorporate into your deck for the next enemy. This forms the basic gameplay loop. There are only 4 types of cards in this prototype. The primary damage card in the game is the basic sword card, which fires a projectile when charged up by slashing enemy projectiles. The second card is a shield card that allows you to block enemy projectiles while recharging mana. The third is a spell fireball card, which does larger damage at the cost of more mana. And finally, the last card is a draw card, which also provides a small heal and allows you to get a new card. Decks are based on a list of card scriptable objects which contain the basic information for the card. The deck gets loaded at the beginning of the match for a player. When you draw your hand, a generic card is created, which is then passed to card scriptable object, which will determine the look and effects of the card. The VR interactions and setup is done using Unity's XR Interaction Toolkit, which is easily extendable, and it's how I added my own interactive elements to the game objects, such as making your sword fire a lightning range attack when you use the trigger button on the controller. One of my focus for this project was to implement solid design principles, as well as to try and avoid creating a massive game manager singleton. This led me to learning more about how to use scriptable objects as a bridge between systems, and how powerful it can be when you combine events with scriptable objects. It's definitely a key learning from this overall project, and something I can see myself using a lot more of in the future as well. The game manager uses a state machine design to keep track of the different states of the game. These states are basically when the player is in the main menu, in the battle state, won state, or lost state. All of these different states have a corresponding UI, which are separated into their own scenes so that they can be loaded asynchronously, and they're able to communicate and be triggered through scriptable objects and events. The main challenge of the game was the enemy AI, which I hadn't created before. I wanted the enemy to behave differently based on what cards the player chooses. So to challenge myself and learn more about building AIs, I basically implemented 2 enemy types based on different frameworks. The first enemy uses a pluggable AI using scriptable objects and a finite state machine, and the second enemy uses a node-based behavior tree which also uses scriptable objects. The first enemy, the finite state enemy, has a base idle state. It checks against a series of decisions whether it needs to change states, and those decisions are based on what card the player currently has selected. Each card selection state will lead to an attack state, which you can then plug in using scriptable objects for what you want to occur. For example, if you wanted to spawn an attack from the left side, you just basically plug in the corresponding scriptable object, which lists position, number of projectiles, and etc. The second enemy uses a behavior tree that relies on scriptable objects. It's not as visually easy to use, but it's fairly straightforward for customizing. You have 3 types of nodes, which are the selector, sequence, and task nodes. It has a default idle behavior, which is to look at the player and wait for a card selection. When the player has selected a card, the behavior tree runs down the corresponding attack sequence. This system currently doesn't have a ton of flexibility, as it is a very basic AI tree. All in all, I learned a lot from this project, and I hope you enjoyed this rough overview of the game systems. The code is available on my GitHub, and if you want to take a closer look, feel free to check it out yourself. And thanks for watching.